this is Karthik Bhatt of class 5C studying in Cambridge Public School. Today in my robotics class, I have learned the concept of different names such as worm gear, blue gear, red gear, small pulley, crank, etc. And my assignment for today was to make a seesaw. This is a seesaw, as you can all see. I have made a seesaw by using this base grid and 3 square frames, 2 white rods and 2 red pegs. I have attached the square frame in the middle and I have attached the 2 white rods together and attached it to the square frame using a red peg. I have attached both the square frames, one by using a red peg and one by using the white rod. Here, if you put more weight, it goes down. And if you put more weight over here, it goes down. If there's equal weight, it will stay in the middle. Just like the seesaw you play and see in playgrounds. Thank you. Bye. Hello everyone, this is Karthik Bhatt from class 5C, and in today's class we learned the concept of the inclined plane. And today's assignment was to create this type of slide. To make this, I used the base grid, 4 white hole dual rods, one to use as the support and one to use to make the stairs. First, to make the stairs, I used 4 3-holed rods. 4 3-holed rods. And I connected them on one side using the 3-hole dual rod and also in the other side using a red peg. We need 4 red pegs because the number of the 3-hole rods are 4. Next, I need 2 curved rods. It has a curve, as you can see. Then we need 2 red axles. We need to use it to attach the curved rods to the white rods. Next, we need a long frame and 2 square frame and attach the long frame to the curved rods, and then attach 2 square frames or 1 frame to the long frame, or like this. So it is like the type of slides which you see in the park. I'm sure many of you would have played in slides at the park. This is a simple machine called inclined plane. Slides have inclined planes. Thank you. Hello everyone, this is Karthik Bhatt from class 5C, Cambridge Public School, and today I have learned the concept in my last class of the wedge and the concept of the screw. My last class's assignment was to create this model. If you turn this crank like this, it will be like a real axe. There's a sharp point over here. To do this, I used the 1 base grid, 2 square frames, 3-hole rods. I used the 3-hole rods because otherwise it will get stuck like this. To stop it getting stuck like that, I used this. And I also used red axles and red pegs to connect the white rod with a bended rod and another square frame tilted like this so that it may have a sharp point. sometimes when you do, it will get open like this. So I tried to create my own extension idea. I did this by using a 5-hole dual rod, and I attached it. I attached it to this. I attached it over here. And I attached another piece. And I made it like, it'll get like this. It'll be like this. It also looks more cool so that you can see over here. Thank you. Hello guys, this is Karthik from class 5C, and in my last class I learned the concept of the lever. A scissor is an example of a class 1 lever. A class 1 lever has the fulcrum in the middle, the effort in the right side or the left side, and the load in the left or the right side. This is the load, this is the fulcrum, this red axle, and this is the effort which we are putting. This works like a real scissor. You can find the scissor in your kitchen. The scissors are used to cut the milk packets and other plastic. To make this scissor, I used 2 white rods, a red axle, a red peg, 2 square frames, and 2 bended rods. It works like a real scissor. And I can also use the scissor to lift stuff such as the base grid. If I move it to a corner, it can lift the base grid and I can place it in my kit. Thank you. Hello guys, this is Karthik Bhatt, and in my last class I have learned the concept of the lever. I have made a wheelbarrow, which is an example of a class 2 lever. In a class 2 lever, the fulcrum is in the left or the right side, and the load is in the middle, and the effort is in the right or the left side. Here, this is the fulcrum, this is the load. We can keep things such as maybe the tire, and this is the effort. I can use this to move the tire from one place to another. If I lift this up, you can find this maybe in farms. Thank you.